So good morning, dear friends. So today we will look at the fourth session on bioorganic chemistry. That will be how we are going to draw the cyclic structure of fructose from its chain structure. Okay, so we'll continue previously. So if you have already drawn the structure of glucose multiple times, its alpha form, its beta form, and the chain form, and the diagrams, then you'll be able to easily draw the structure of fructose. Okay, so we'll go into the cyclic structure. So here you can see at the right hand corner of the screen, the structure of fructose. Okay, so you can see the structure of fructose. So as mentioned earlier, you have to sorry. So here on the right hand side of my screen, you can see the cyclic structure, sorry, the chain structure of fructose. So as mentioned earlier, you have to just rotate the structure and draw it in a horizontal fashion and mention the groups as it is. So here you'll have the CH2OH, and here you will have the double bond O, and then you'll have the OH group on the top, the two OH groups at the bottom, and then you'll have the CH2OH group at the tail. Okay, so that's how you'll be, drawing the structure, and then you draw it in a five-membered ring fashion. So you can see the OH group is on the top here, the second OH group here is here, and the last carbon, as I told you, there was a rotation. So we said we are rotating. So we're pushing this OH group to form the bond with the keto group and maintain the CH2OH group here. Okay, so now. So please keep, drawing as I lecture. Okay, please see that you keep drawing as I lecture. Otherwise, it will be difficult for you to, pull things up later. Okay, here what I've done is, they have simply added a proton to show you a mechanism of the reaction. But you can avoid this. I'll tell you what to do exactly. So you have the OH group here. So this is the OH group from the fifth carbon. So you can see the number 5 mentioned here. So this is the OH group. So it is going to attack the keto group. So there was previously aldehyde here in the case of glucose, but this is, this is the second carbon of your fructose. Okay, so if it was glucose, it would have been the first carbon and there will be a hydrogen group here. No, it is going to form a cyclic ether. So it attacks here and the proton jumps here. So that's all we have. So it is coming here. Okay, so we'll remove this proton. So this proton we can remove. Okay, so it is not a problem for you. So you just leave it alone. So this proton jumps here and it forms an OH group. So now I told you that the keto group, similar to the aldehyde group, is going to be a planar molecule. So when it attacks, it can either attack from the top or it can attack from the bottom. Okay, so when it attacks from the top, it forms a OH group below, and when it attacks from the bottom, it forms an OH group at the top. So if the OH group is at the top, then we call it as what? We call it as an beta structure. So here what they have done is the beta structure of furanose. So this is a fructofuranose. So you would have seen, the structure of furan. So this is your structure of furan. So tetrahydrofuran, this is your structure of tetrahydrofuran, and this is your structure of your pyran. So we understand why this is called as furan and this is called as pyran. Okay, no. So we can see the OH group has come on the top. So this is the attack from the bottom side of the molecule. So the OH falls on the top. Similarly, when the OH attacks from the top, you will get a OH below. So you can see here the name that is mentioned, alpha D fructofuranose. Alpha D fructofuranose. Okay, and here again you can see it is mentioned as beta D fructofuranose. You can see the molecule that has been mentioned here. Okay, so these two are again called as what? These two are again called as anomers. Okay, these two are again called as anomers. Now, I wanted to tell you something that which I previously did not mention, because In this particular slide, it has been mentioned. So you can see here that there's something here that they have called as trans alpha. The trans is called as alpha, and the cis is called as beta. Now, normally when we mention the CH2OH group in the Harvard projection, we mention it in the axial position. So you can see that in the Harvard position, you can see that the Harvard projection, you can see that the CH2OH group is in the axial position. Okay. Now, if the OH group that is being formed, if the OH group that is being formed is going to be, cis to the CH2OH group, then it is called as beta form. If it is going to be trans, if the CH2OH is going to come on the top and the CH2OH is going to come at the bottom, then it is going to be called as trans fructose. So this is the relation. So trans sugars and cis sugars, that's what they will classify them as. This is a means of class. Okay. So similarly, a six-member ring is also possible for similarly a six-member ring is also possible for fructose. But why is it only that a five-member ring of fructose has been mentioned is that whenever fructose combines with other sugars to form, disaccharides or, linked sugars, that is using glycosidic linkage. That is when two molecules join together. So if you're going to link two, you know, polyhydroxyaldehydes, or if you're going to link two polyhydroxyketones, so in such combinations, it exists as a five-membered ring structure. So if it is going to, exist as a single molecule, then it will exist as a six-membered ring. Now, how come the six-membered ring? The OH group will drop below here, and the CH2OH group will form the OH group here, and this will again form a anomer. Okay. So usually fructose is usually in its combined form, so we do not mention the six-membered structure of fructose. So dear friends, please see that you keep writing these molecules repeatedly, and if you do not understand, feel free to approach me. I will be able to help you out. Only through pen and paper will organic chemistry come out well. Otherwise, you will have a lot of difficulty getting along, especially with carbohydrates. So thank you, dear friends. We will meet in the next session for DL notation. Okay. So as of now, I'll just close down. Thank you for your patient listening.